Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to p-value and significance level. So, p-value and significance level are heavily used in the testing of hypothesis. So, to reject or to accept the null hypothesis, so this p-value comes into the picture. So, what is this p-value and what is the significance level? Okay, and how it's been denoted and how we are finding it, and then by using that what we are getting it. Okay, that everything we are going to discuss at this video. So let's get started. So first of all, let's understand the significance level and then we will be moving to the p-value part. So okay, so significance level, it's been denoted as alpha. Okay, is a predetermined threshold used in the hypothesis testing to determine whether the null hypothesis should be rejected or not. So here is the distribution. Okay, over here you are getting a data, the shaded part, right? So this it's nothing but when you are getting a value. Okay, if you determine the predetermined threshold, you're giving as predetermined threshold as 0.05, for example, that if it follows inside this shaded part, that is nothing but to accept the null hypothesis, right? Accept the null hypothesis. If it's not falling in this interval, okay, if it's falling in this part of the region, then it's said to be as a fail to reject the null hypothesis. Fail to reject. That is nothing but it's not having the enough evidence to accept the null hypothesis. Even we can say it in that way also, so that we are accepting the alternate hypothesis. Even we are using the alternate hypothesis over here, right? Okay, we will be discussing more related to hypothesis in the coming videos, but just understand what is the prevalence significance level because it comes again and again in your questions. Okay, so if your value is falling over here, if your value is falling over here, then what you will be saying, you will be saying that I'm having the enough evidence to accept the null hypothesis, right? To accept it. So if your data point, or if your value falling over here, if your value falling over here, then you say that we have failed to reject the null hypothesis. So there are two different types of the condition that you will be getting again and again in this. So alpha, it's nothing but we are denoting as alpha, so it's nothing but significance level. It's nothing but significance level. That is nothing but this part. Okay. So alpha is equal to significance level. And alpha can, and this part it's called as a confidence interval. It's called as a confidence interval. So there is another type of the writing also. So alpha is equal to significance level. This is called alpha. There is another way of writing also. That is nothing but alpha is equal to 1 minus of confidence interval. Why 1 minus of confidence? So the area under the curve, the area under the curve is equal to 1, is equal to 1. So if its area under curve is equal to 1 minus the confidence interval, so this all are the confidence interval. So if I will subtract 1 minus confidence interval, okay, the complete area is equal to 1, and if I will be subtracting the shaded part by 1 minus confidence interval, then I will be getting this part, then I will be getting this part, right? 1 minus this part, then I will be getting this part, right? So same thing I have represented over here. 1 minus confidence interval. So there are two way of writing. Alpha is equal to significance level and alpha is equal to 1 minus of confidence interval. Now we'll just move to the p-value and we will be discussing about it, and then after the p-value or significance level we will just compare it and how we will be using it, that we will be discussed. Okay, thank you. So now let's start with the p-value. So what is this p-value? So is the probability of getting a sample as or more extreme having more evidence against H naught. So H naught is nothing but null hypothesis, and H1, it's nothing but alternate hypothesis. So whenever they are denoting h naught and h1, then you need to understand what they are saying it. Okay. Then our own sample given the null hypothesis h naught is true. It's a measure of the strength of a evidence against the null hypothesis that is provided by our own sample data. You're getting a p-value, if you're having a p-value as 1.99, and in another condition you are having a p-value as 1. For example, just take it, and your significance level, that is nothing but your alpha. Okay, here I will be giving as 2. Here you will be having as 2. So you can say that 1.99 is less than 2 and 1 is also less than 2. As in one condition you are getting as 1, it's nothing but it's quite away from that particular significance level, right? It's quite away from the significance level, but 1.99, it's quite near to the significance level. You couldn't able to say it's near, it's almost a significance level only. Okay, so the accepting or rejecting the null hypothesis, but the percentage that you're getting, what's the probability, the values that you're getting? Like in my first condition, it's quite near to the significance level, but it's quite away from the significance level. So whether you are accepting or rejecting, whether you are accepting or rejecting, it's up to the value that you are getting. But the probability, the strength of the value, it gives the strength of the particular value. So if it says that your strength is around 0.99 to accept it, so it means that around 90 percentage it's saying that to accept the null hypothesis. It means it has the enough evidence to accept the null hypothesis. For example, in the second condition, you are having to accept the null hypothesis. You are having, for example, in my first condition, you are having the uh, probability value to accept the null hypothesis, it's around 0.1%. So we say that 10 percentage only you are having the evidence to accept the null hypothesis. But my second condition almost has a 90 percentage. So the strength is different. Though the value is less than 2, less than significance level, so we are accepting the null hypothesis. But the strength that you are saying, one you are getting as 10 percentage to accept the null hypothesis, and another you are getting a 90 percentage. So the strength, how you are getting, how you are finding it, so that you can do it by the p value. Okay, so what is that the p value, that whatever you will be getting it. Okay, the p value is the probability value, right? So the probability value that you will be getting, it lies between 0 to 1. Okay, it actually is a decimal value like 0.9, 0.85, something like that. So based on 0.85 you can calculate the percentage, you can calculate the 85% or something like that. Okay, where the assumption that the null hypothesis is true or enough evidence to accept the null hypothesis, that we can understand by the null hypothesis. So we can, if it is less than that significance level, if a p is less than is equal to significance level, then we are accepting the null hypothesis or we are rejecting the null hypothesis, or something happens with this, right? But what is the strength of that? Is there is any enough evidence to accept the null hypothesis? Like in the diagrammatical itself, I'll just explain it over here. So this is my distribution over here. You can see the observed value, it's quite near to the significance level. Okay, if this is the significance level, the data points lying over here. So the strength of the p value will be quite less than if the data point is lying over here. Okay, the p value will be quite strong over here. So at that moment, to find the strength of it, is there is any enough evidence to accept the null hypothesis, or we are quite near to that. For finding the strength, we are finding this p value. So we are very, they have, in a very proper way they have used significance threshold corresponding to a given significance level, example 0.05. So they have given an alpha value as 0.05, and are getting a p value something is less than 0.05. So but it's quite near to 0.05, like it will be around 0, alpha is equal, so it's quite near to 0.05. So for that, so is there is any enough evidence to accept the null hypothesis? So for that, whether it will be, whether the strength of accept the null hypothesis or to reject the null hypothesis, so what's the strength based on it, that we can find it through this p value. Okay, so It's a part of a decision making. So whenever we are working in a decision making, so by using the probability, we used to find the percentage, how much our hypothesis has the evidence to fight for true. Okay, how much evidence it can fight for the false statement. So the percentage that you can get it. Okay, so basically the probability values that lies between 0 to 1. So by that, by the decimal value you can find the percentage. So by the percentage value only you will be getting that to is there is any enough evidence to accept the null hypothesis, or is there is any need for the rejection of the null hypothesis. Over here they have represented as 0.05, right? So it's nothing but 5% of the data. 5% of the data comes under the alternate hypothesis. So this 5%, or sometimes used to use with 1% or 2.5%. Okay, it differs. So based on the data that we are using and based on the domain that we are working, it differs. So this all percentage value will be done by the domain expertise. So what percentage will be accepted and what percentage will be rejected, that will be all done by the domain expertise. This percentage that they will be deciding. So based on that we can work upon it. Okay, so if we are using very small p value, so first condition, p value is less than 0.01. Okay, very small percentage, that is nothing but 1 percentage. And that too also if there is one tail test. Okay, that is the difference between one tail and two tail test. Okay, one tail test is nothing but when you are having a distribution and you are using a significance level only in one side, then it's set up as one tail test in a simple way that I'm understanding. So one tail test, two tail test, one sample, two sample, paired test, that we will be discussing in the coming videos, but just understand it. But if that will be some type of diagram, you can see it in the Google, that you can Google it out, that there will be certain type of the distribution in which you will be having a two cut at the left hand side and the right hand side. Okay, so if the 10 percentage, if the 10 percentage significance level, the domain expertise the domain expertise have accepted it, then we used to give the 5 percentage over here and 5% over here. Okay, the left hand side and right hand side based on the domain that we are working. Okay, so as of now we are using one tail test sample example only. So over here, if the p value is less than 0.01, very small p value, very small p value, indicates strong evidence against the null hypothesis, suggesting that indicates that strong evidence against the null hypothesis, very strong evidence, positive evidence against the null hypothesis. So I will repeat again. So if the p value is less than 0.01, it's having a very smallest value, okay, in which it says the strong evidence against the null hypothesis, suggesting that the observed effect or difference is unlikely to have occurred by chance alone. Okay. Now let's take the another condition. If the p value lies between 0.01, that is nothing but 1%, if I'm using the one tail test, okay, to 0.05, it's nothing but 1% p value to 5%. If one tail test, if one tail test, then directly I will be using a 1% over here. Okay, if I'm using a 5% it over here, so directly I will be using a 5. But if I'm using a two tail test, then I will be using a 2.5 over here, 2.5 percentage over here. So I will be distributing in that way. Okay, if the p value lies between 1% to 5%, indicates that moderate evidence against the null hypothesis, suggesting that the observed effect or difference less likely to have occurred by chance alone. Okay, less evidence against the null hypothesis. If we have the larger p value, like 0.05 to p is less than equal to zero point 0.1, 5 percentage to 10 percentage of the data indicates weak evidence against the null hypothesis, suggesting that the observed effect or difference might have occurred by chance alone, but there is still some level of uncertainty. P value is greater than 1.1. If p value is greater than or equal to zero point 0.1, is nothing but 10 percentage of the data is in the significance level. Okay, if that condition, it means a very large p value comparative to first, second, and third condition over here, 0.01 zero 0.01, over here 0.05, and over here 0.1. And if it is greater than 0.1, so it's comparatively larger value, larger p value, so which indicates that weak or no evidence, weak or no evidence against the null hypothesis, suggesting that the observed effect or difference is likely to have occurred by chance alone. Okay, so over here, if the p-value, I'll just repeat once again, p-value, if p-value is less than 0.01, then we have the strong evidence against the null hypothesis. But if the p-value lies between 0.01 to 0.05, that is nothing but 1% to 5%, then we have the moderate evidence against the null hypothesis. But in the third condition, we are having a 5% to 10%. So at that moment, we have the weak evidence against the null hypothesis. But if it is greater than 10% of the data, that is nothing but zero point 0.1, then we have weak or no evidence against the null hypothesis. So this are the four different types of the condition which comes into the picture. So these are the four different types of the condition which comes into the picture again and again when we are using a testing of hypothesis. So in my upcoming videos, I will be explaining with the examples. So whatever the Z test, T test that we will be learning, so that we will be understanding with the example. I hope this video find it out so useful. Do like, share, and subscribe to Data Discovery. I will be coming across more videos related to data science, data analysis, ML, DL, and all the algorithms, and then the most important, all the coding part also. Thank you.